pass by value, or as we call it here, pointers of memory, is something that's very vital to JavaScript. It's one of those things that's always running in the background, so it's not something that you actively use, but it underlies a lot of JavaScript fundamentals in terms of how things look and how things can change when different values are being passed back and forth. So what does that mean? Let's get started here. So we're going to go back and do a quick review of primitive versus complex data types, as well as variable assignments. And then we're going to start talking more about what it looks like when we actually use these values inside different functions. Okay, so just a quick recap, and this hopefully is a refresher more than anything else. Remember how there are 6 primitive types, data types in JavaScript. There's strings, numbers, and booleans, which are the 3 that we've been using the most. There's undefined, there's nulls, and there's symbols, which we haven't really touched on nearly as much. But those 6 are the primitive data types in JavaScript. And then on the complex data types, we have objects, which also includes arrays, and functions. So recall what makes a primitive data type primitive as opposed to a complex. Well, the primary kind of feature that makes something primitive means once I create a data type that's a primitive data type, I can never change it again. Okay, so if I make a string called ABC, that string will forever be ABC. If I ever want to add another letter to the end of that string, I can't. The only thing I can do is take those letters and then make a brand new string with those 3 letters and adding 1 additional letter or taking away any number of additional letters. But the core idea here is that once I create something, I can never ever change it. I can only create a new one, right? So when I create a number or a string or a boolean, once it's been created, I can never change that value. Okay, and that's the contrast with something like objects or arrays or functions, right? If I think about an array, if I have an array with 3 things and I want to add something to it, that's totally fine, right? All I got to do is do array.push, and that will take that new element or that new unit and shove it to the end of the array. Similarly, if I want to do anything else with objects, same idea. I can replace key value pairs, I can add new key value pairs, I can delete key value pairs. And so what sets apart a complex data type from primitive is that after I make a complex value, I can always opt to go back and change that value, right? Edit it so that the value becomes something else. And the reason why that's really important here is when we talk about when we're passing a unit back and forth, what behavior do we observe? Okay, so let's take. Oh, sorry, I realized I didn't start slide mode. Okay, so let's take a look at what happens when we or rather, let's take one aspect in terms of how we use primitives. So here we have 2 strings. One's called British City and one's called American City. Notice how British City is equal to the string York, Y-O-R-K, and then American City, we set it equal to British City. Now, if I replace the old value of American City with the string new plus American City, and I console log out British City and I console log out American City, so I'm just going to zoom out really quick so I can move this screen here. Okay. Yeah. So if I console log out what I get, if I console log out the 2 strings I've just edited, you'll notice how on line 7, when I console log out British City, it's still York, right? It's still Y-O-R-K. British City never got changed. But if I console log out American City, we'll see that American City now becomes New York. And so the question that we're trying to get you to think about is, well, why did British City not change, right? On line 2 there, we said British City equal to Y-O-R-K. On line 3, we said American City equal to British City. And then on line 5, we actually edited American City by prepending the word new to it. So why did American City change and why did British City not change? This is going to be what the focus of today's lecture is going to be on. Okay. If, on the other hand, I take a look at a comparable, which is to say, if I take a look at something that used a complex value, so in this case we have an array with a string York. Now when we say British City is equal to the array York, I set American City equal to British City, and I unshift, as in if I add another element to the beginning of American City. Now when I console log out both British City and American City, you'll notice both British City and American City have the same value, or rather they both have become the same value, which means that whatever I did to American City also changed British City. In the previous example, British City was the string York and it was not changed. Here, British City is the array with 1 element, and in this case, it was changed. So this is kind of why it's important for us to be very clear especially when we're in JavaScript or we're trying to use different data values, whether or not something is primitive or complex, because they're going to exhibit different behaviors. Okay, cool. So let's get started here. Why do they behave differently? So what fundamentally is happening whenever we talk about assignment is all we're saying is there's an equal sign somewhere in the equation. Okay, and so when we say when you assign a primitive value to a variable, what we're really saying is there's a value which in line 4's case is 20, and then there's a variable which we call first. And this is a part where it takes a little bit of getting used to, but hopefully once you do, everything will click. You can think of first as saying, hey, if anyone ever asks me what value I am, I'm just going to have a pointer. I'm going to point to another value. And in this case, first is pointing to the value 20. Okay, and that's what we're trying to indicate with the box on the bottom right-hand corner of your screen. Now, if ever we decide to reassign the value of first, and we say, hey, first, you're no longer 20, you're now 30, all we're really doing is we're just repointing the variable first to the value of 30. Okay, we're not changing 20 and adding 10 to it. We're just saying, hey, you are now the value 30, right? If you can think of each of these values as like a different address or a different house. Basically, before on line 4, when we did first equals 20, all we're saying is, hey, you're pointing to this house, right? And then if we ever reassign the value, all we're saying is, hey, now you're pointing to another house. You're pointing to another value. So once again, we're not editing 20 by adding 10 to it. We're pointing to a whole brand new value called 30. Now, on the other hand, if I have another variable and I say let second equals 30, notice how even though the value 30 exists, or rather, even though the variables first and second are both equal to 30, notice how they're actually pointing to two different versions of 30. Or either they're both pointing to 30, but the 30s are separate, right? Each of them is pointing to their own version of 30. And the reason why that's important is because if I ever edit second, if I say, hey, let second equals 30 plus 1, well, second now points to 31. But first is never changed, or rather the first is never touched. And so this brings us to kind of the first main idea, which is that whenever we say two variables are equal to the same value and the value is primitive, that always means that they are pointing to different versions of the same value, right? It's like saying if I have a car, let's say I have a Honda, right? And my friend has a Honda. We may have the same vehicle in terms of make, model, year, etc., but we basically have two distinct cars, right? Whatever I do to my car will not impact his or her car. And so the same idea here applies, right? First is equal to 30 on line 5, and then on line 7, second is also equal to 30. Yes, they're pointing to the same value, but those two values are distinct. They're not related in any way. So whatever we do to first will not impact whatever we do to second. And this actually points to a very fundamental idea of JavaScript. So here we'll see once again we have our first is equal to 20, right? And the variable first is pointing to the value 20. On line 2 we say let second is equal to first. So what happens here is something that happens only for primitive data types. Okay. Because primitive data types are not able to be changed, when we set second equal to first, what we're really saying is, hey, second, you're equal to the same value as first, and guess what? That value can never change. So rather than pointing you to the same value, we're going to give you your own copy of the value, right? So on line 2 there, the comment that says second stores its own value of second stores its own copy of the value 20. That just means that that the variable second looks at the variable first and it asks the variable first, what's your value? And the variable first will say, oh, I'm 20, or I'm pointing to 20. Second will then say, oh, well, 20 is a primitive data type, so I don't need to store that exact version as you. I will store my own version of that value. And so in the bottom right hand corner of your screen, you'll notice how second is pointing to another value, also called 20. And more importantly now, on line 4, when we add 1 to second, we do second plus plus, that now changes the value of second to 21. But because second was storing its own copy of 20, those two never overlap, or rather those two don't impact each other. And so even though we're incrementing second by 1, first never changes. Okay, and so this is what we mean when we say pass by value, as in primitive data types are passed by value. And on line 2 there, we're basically passing the value of first to the variable second. And when we pass, we're passing is the value of first. Rather, we're saying, hey, second, my value is 20, so why don't you become your own version of 20? Or rather, why don't you point to your own version of 20? Okay. So far, so good? Right. The short of this is just that for primitive data types or primitive values, we always pass the value. Okay. In fact, for primitives, as a good rule of thumb, just know this: for each individual primitive value, whether it be a string, a number, or a boolean, you will never have more than one variable pointing to it. Okay. So on the bottom right-hand corner of your screen, for that value of 20, you will never ever have more than one variable pointing to 20. We could have multiple variables, each pointing to their own version of 20, and we could have multiple variables pointing to different values. But we will never have more than one variable pointing to the same value, because whenever another variable tries to point to that value, it will just create its own copy of that value instead. Okay, and this is only for primitives. So if we shift back now and we look back to complex data types we talked about earlier with arrays and objects, the big difference here between complex and primitives is when we try to pass or we try to assign a complex value, the variable does not make a copy of the value and store it, and instead what we're actually doing is we're actually storing that exact instance of that value. So let's take a look at what that looks like. So here on line 7, we have a variable called first. It's equal to the array with two values, 10, 20. Okay? Now, on the bottom right-hand corner of your screen, notice how we've now included this extra. We still have our old variable first. We still have our value, which is the array. But in the middle now, we have this slot called reference. Reference is just a fancy word for address, right? It's just by saying, where in the memory are you? And so when we talk about modifying a complex data type, notice how here on line 8, even though we're adding an extra element, we're adding 30 to the first array. Notice how the reference, the address, does not change, right? Because we still, when we edit first, when we push 30 on the first will say, oh great, I'm pointing to this address, and this address will say I'm pointing to this value, and we'll say, oh great, that value is editable, so therefore let's just edit it right away. Okay. Remember how we can't do this with primitives? If I was to do, if first was a number and I tried to edit that number, I just create a brand new number. Here, I'm not creating a brand new anything. I'm actually editing an existing array that I already have. So far, so good? Okay, we have one more slide left, and then hopefully this will become a lot clearer. If, however, we try to do, okay, sorry, so this is an kind of just, this I think people get intuitively, even though on line 1 and 3, even though first and second are both equal to the same value array, those two are completely distinct arrays, so whatever I do to one will not impact the other. Okay, I think people are usually pretty comfortable with this. So this is just to show that even though I have two arrays with the same exact values, in this case I have an array, each with a value number 10 and a number 20, even when I edit one of the arrays, it does not impact the other one because both of them are being stored at different addresses. Okay. And then the last scenario we want to take a look at is what happens when we actually try passing this value back and forth. So let's take a look at this now. I have my variable called first, and it's equal to an array with 10, 20. And then I have my variable second, which is equal to the first array. Now, what this basically has us doing is, and let me just edit it as out, like I can actually move this to the bottom right hand corner of the screen, so I can see. Okay, cool. So what this is basically doing is we're actually saying, hey, when we try to pass the value of first into second, we're not going to pass you the value of first. Because when we pass you the value of first, that tells you to make your own copy of first. Instead, we're going to pass you the reference, right, or the address of this value. And so second now is actually going to point to the same exact address as first. And so on the bottom right hand corner of your screen, the arrows are a little bit misdrawn. Both the variables first and the variable second should be pointing to the same reference, which is pointing to the same value. So actually, let me just fix that right now. Sorry, I should have done this a bit earlier. Oh God, what did I do? Magic. Oh man. Sorry, folks. Technical difficulties. Okay. Great. Right here. Great. All right. What I want to do is I basically want to edit this really quick. What? I'm sorry. Yeah, it does not like me editing that thing. But I am stubborn, so I'm gonna try one more time. Now I'm scared. Okay, yeah, it just really does not want me to edit it. Okay, well, hopefully you get what I'm trying to say here.
Try just putting a new arrow on it.
I'm just gonna not touch this anymore. I don't know if I can move this. Oh, maybe I could. Yeah. Can I shrink this? Okay, there we go. Can everyone see? Hopefully this isn't like super confusing. Okay, well I guess it didn't even bother reflecting my changes.
You gotta save.
Oh, do I? When a president is only press the save last save version? Nope. All right. Well, anywho, I think you get the idea. Basically, for the variable first and the variable second, when I pass first into second, I'm not passing the value of the array. I'm passing the reference or the address of the array. And so basically now the variables first and second both point to the same reference, which by default means they must also point to the same value, right? It's like if I'm in a town and I have two people that are both delivering a package to the same address, well, by definition, they have to both be going to the same house or the same location. So same idea here. And so, oh, I guess I changed it on the second, on the animation part. But now whenever I push 30 onto the second array, well, because both variables are now pointing to the same reference or pointing to the same value, whatever I change, whenever one of those variables changes the underlying value, guess what? It's going to change it for the other person as well, right? So if the first delivery person gets to the house and and paints the door red, then when the second person gets to the house, the door will already be red, right? Like that's by definition what it means when we say you're pointing to the same value, which is that if one variable edits a value, then that value must be edited for any other variables that are also pointing to it as well. And so this is why a lot of times you might see us use the slice function that we talked about when we talked about arrays. What slice does is say, hey, let me go through and actually let me create a brand new copy of the array, right? So if you look in the bottom right hand corner of your screen now, first is equal to this array called this array with 1020. It's in a certain address. When I say let second equals first dot slice, what I actually do is I actually copy the value of first. I create my own version of this array with those identical values. But most importantly, look at the reference. First now points to one reference, which points to that value. The variable second points to another reference, which points to something that happens to have the same value, right? And so all this just means that now whatever I do to my second array will not impact my first array, because look where the arrows are pointing, right? First is pointing to a reference, which points to a value. Second is pointing to another reference, which points to another value. And when I change that other value, it has no impact on the original value. Any questions so far? Let me go back here.
One,
Yeah, go ahead.
where in the first in the primitive type when you did like second plus plus,
Yeah.
it changed the value, like it incremented by one.
Mm-hmm.
But when like so let's say the example you took was first equal to 20.
Yep.
But let's say first equal to first plus one.
Yep.
In that case, again, first will make a new copy where it will copy the value of 20 and then add one.
Yeah, you can think of it like that. Well, in that case, I don't know if first creates a new version of 20. It might just like do the computation and say, oh, you want a 21. Here you go. And it'll give you a brand new number called 21.
So you can make like add or subtract, then it is in the same location.
Yeah, for our purposes, you can think of it as doing the operation in place. I don't think it goes through and makes another one. Mostly because, yeah, I mean, there'd be no benefit to making another copy, right? Because it knows what value it already is, so it would just use that value. Um, for primitives, the magic, I guess, is more in the idea that like when I'm using it somewhere else, I pass another version of it. But if I'm trying to use the operation directly, then it'll just give me back the brand new value.
And in case of arrays, when let's say it's an array of strings.
Yep.
And then if I change the string value, in that case, it is working on the same memory location.
Yes. So let's just take a look and make sure I understand your question. So what you're saying is if I have something like let x equals, and I say I'll have an array of ABC, right? So what you're saying is if I say x index 0, and then, I'm sorry?
And change the string.
Okay, so how do you want to change it? Just add another like D?
No, if I say x0 equal to.
Okay.
Let's
Sure, let's do the F. Yep. And then now when I print out x, I get back df, right? Because because x is an array, right? So I'm changing the array. Now, if I do x0, yeah, it's a little bit tricky now. Okay, if I do something like this now, now notice how what I'm doing here is I'm actually going inside. I'm replacing the original array, the original string with a brand new string. Cool. Yeah, no problem. Oh yeah, I'm already sharing. Okay, cool. So yep, so that's the complex values. Okay, so when do we see this in the wild, right? Like right now, like I've done a lot of like kind of arrow drawing, and it seems kind of like, oh great, like it's interesting, but when do we actually see it? You've actually been using a lot of it. And so let's take a look at some common times in which we pass values from one place to another. One of the most common ones is whenever you write a function, usually that function takes in a value, right? Usually it says, hey, give me a string or a number or something, and let me do something to it or with it. Well, when we put a value into a function, that's called passing a value into a function. So when we talk about passing in a primitive, so in this case, let's pass in a number. Notice how in the layout of this code, on line 3, I have a function called adds20 that takes in a number. On line 4, we add 20 to number, and we set it equal to, and we replace the original value of number with that resulting number, and then we return the number, num. Okay, so on line 8, when we say let return num equals adds20 my num, basically that basically says, hey, let's pass my num, or let's pass in 10 into the adds20 function. Okay, so now we're in line 3, num is equal to 10. Go to line 4, 10 is equals to 10 plus 20. So basically num is now 30, and then I return num, I return 30. So that means on line 8, return num is equal to 30, but when I console log out my num, it's still 10. So why does that happen? It happens because on line 8 there, when I pass in my num into adds20, JavaScript's going to take a look at that and say, oh great, what is my num? Is it a primitive or a complex data type? And because my num is a number, we'll say it's a primitive data type. And so because of that, we don't pass in my num itself. What we're actually passing in is a copy of my num's values, right? Remember, primitives are passed by values. So we actually just take in the value of my num, which is 10, and we pass that into the function. Then let's contrast this with how this will work with a complex value. So here, the layout of the code is almost identical, except now instead of adding a number to whatever is passed in, we're going to expect an array. And we're going to add 20 to the end of the array. So we're basically going to add an extra element to the array. Now, when I look at this code, I say let a returned array equals pushes 20, my array. And more importantly, when I do this now, what I'm actually going to get is now on line 8 there, when I pass in my array, JavaScript's going to look at it and say, okay, great, what's my array? Is that a primitive or a complex? It'll look on line 1 and say, oh, it's a complex value. It's an array. So I actually pass in my array into the function on line 3. It goes to line 4. We add 20 into the array. And then on line 5, we return the array. And on line 8, we stored whatever array was returned into the return array variable. So on line 10 and line 11, when I console log out both my array and return array, they are both pointing to the same underlying thing, right? My array is obviously pointing to the array that was passed into the function on line 3. And so whatever we do to that array is going to change, is going to be reflected in my array. And similarly on line 5 there, when we return the array and we store it in returned array, well, returned array is pointing to the same array that was passed in, which is also my array. And so now, basically, because I passed in the original my array value as opposed to a copy of my array, that's why whatever happens to my array inside the pushes 20 function, it will be reflected outside of the pushes 20 function as well. Does it make sense, everyone? This is a big idea that we're trying to get across it, right? Which is just that whenever you're using a primitive data type, whenever you pass it anywhere, whenever you move anywhere, you're always passing a copy of the value, right? It's always saying, like, let's say you have a really valuable, like textbook, right? Like, or a note or an essay, right? When someone asks you for it, you always Xerox it and you give them a copy of it. That's primitives. With complex data types, you're actually saying, hey, here's my underlying essay. Here's my underlying notes, right? In the previous example for primitives, if I give you a copy of my essay and you take notes on that copy, guess what? I don't feel any impact of it at all, right? Like my copy is going to stay pristine. However, if I give you my original essay and you start taking notes on it, well, guess what? When I get my essay back, that essay is going to have notes on it, right? Because I'm actually giving you the actual physical thing with a complex data type, whereas with a primitive data type, I'm just giving you a copy of it. Any questions on this concept before I move on to one of the last 2 or 3 slides? Cool. Well, if not, then let's just wrap this up really quickly, right? So now we go back to our old friend, the triple equal sign. You know, remember how earlier we talked about why I could have 2 complex data types? I could have 2 arrays with the same exact values, but when I use triple equals on it, I will get back false, and it might seem strange. Well, the reason why is because with the way that the triple equal sign works is when it compares primitive data types, there's no confusion, right? It's just, hey, you're both strings. Like you have to both be strings and have the same characters, or you have to both be numbers and have the same numerical value, etc. With a complex data type, it's not enough that you have to have the same value, but you also have to have the same reference. So if I make array 1 and array 2, even though they have the same value, they have different references, right? Because they're both distinct copies of the same value. And so when I do array 1 triple equals array 2, I get back false. However, if I do array 1 equals 1, 2, 3, and I set array 2 equal to array 1, now array 1 is going to pass by reference. It's going to pass its reference to array 2. So array 1 and array 2 are both going to point to the same reference, which is going to point to the same value. And so now when I compare array 1 to array 2, I get back true, because the triple equal sign takes a look and says, hey, you're both complex and you're both pointing to the same reference. Therefore, I know you have to have the same value, and therefore you must be true. So this is why triple equal sign works the way it does, and that's why you also should be really careful when you use it to compare complex data types. Okay, the very last thing we'll talk about is this idea of slice or making a copy of an array. Basically, what slice does is it creates even though it creates a copy of an array, what we say is that it actually creates a shallow copy of an array. So what does it mean to make a shallow copy of the array? If I look at the array on line 3 there, right? I have array 1, and the first element inside that array, well, it's a number, right? So whenever I make a copy of a number, I get a copy of the value, and that value is distinct, right? Pretty straightforward. However, the second element is an array with the numbers 2, 3. If I was to make a copy of that array, if I was to make a copy of array 1 with dot slice, what dot slice does is it actually goes through every single element, and if that element is a primitive, it will make a copy and create a brand new copy of that value. So for 1, it will create a brand new 1 value. But if the value of the element is complex, what it'll actually do is it will actually transfer over the reference. Okay, it will actually transfer over the reference of that second element into the new array. So what that means is on line 6 there, when I console, so on line 1 I create this array, right, with a nested array as a second element. On line 4 I create a brand new array called array 2, and I set equal to array 1.slice. If I console log out array 2 looks just like array 1. But when I try to use the triple equal sign to compare array 1 and array 2, I get false, right? And where does that false come from? The false comes from the fact that for that 1, that first element, array 1 has its own copy of 1, and array 2 has its own copy of 1. So therefore, those two don't share the same reference. However, if you go back to the same example now, line 7 creates the array, line 8 we create a copy of the array using shallow copy. On line 10 there, I go into my original array, I go to the second element, and I add 4 to it. So now in array 1, the first element is 1, and the second element is the array of 2, 3, and 4. If I console log out the corresponding second element in array 2, and in fact, if I try to compare those two elements, I get equal signs, or with triple equal signs, I get back true. And what that means is, once again, when dot slice went through array 1, it went through every single element, and if the element was a primitive, it created a brand new copy of the value. But if the element was complex, then all it did was take the reference of that complex value and add that reference into the new array. And so therefore, both arrays still share the same link. In this case, both array 1 and array 2, even though we made a copy, even though array 2 is technically a copy of array 1, they both still share the same reference to the second element. And so one of the things to work on in your workshop tonight is recognizing the limits of shallow copy and dot slice, and trying to figure out, is there a better way for us to make a deeper copy, right? Or a copy that actually goes through and is able to definitively create two distinct copies of an array that are not linked at any juncture. Okay, so just a quick recap. We went over primitive and complex. Primitive means once I create a value, I can't change it. Complex means I am able to change it. We talked over variable assignments, and we talked about passing the values into functions, right? So variable assignment just means, hey, for primitive data types, I pass by the value, right? If it's a primitive, I'm going to make my own copy of the value and use that copy. If it's a complex data type, then I use that actual version of the complex data type, right? There are no copies. It's just the same exact thing. I then talked about how we, depending on whether or not something complex or primitive, when we pass into a function, what happens to it, right? Do we edit the original? Are we modifying the original one into the function? Well, we are if it's a complex data type. However, if it's a primitive, then we're only modifying a copy of it. And we talked a little bit about the equality operators. So why triple equals work the way it does? It's because when a triple equals compares complex data types, it's only comparing it by reference, it's only comparing by reference, not by value. So something could have the same value and not have the same reference. But if two things have the same reference, then they by definition have to have the same value. And then lastly, we talked about arrays and slice. Slice makes a copy of an array, but it only goes one level deep, so to speak, right? It only goes through element in that array. If you have complex data types in your arrays, well, slice won't separate out the copy from the original, and both the copy and the original will still share that same complex element. Any questions? Everyone good? Yeah? All right, cool. Yeah, this workshop, just so you all know, it's a little bit challenging. So definitely like don't feel bad if you don't make it all the way through. Obviously, do your best. But this is a little bit tricky. And like I said, a lot of this is being used without even realizing it. Like you've been using pass by reference and pass by value every time you write a function to the test call. So it's all around you. It's more a matter of you making sure you understand what's going on, as opposed to trying to say, oh well, I just never use this. Like you're gonna have to use this at some point in your programming career. Okay, so I'm going to stop the sharing and then I will break you off into groups.